Some species of plants and animals rely completely on forest interior habitat. This is defined as an area that is away from canopy openings like a road, harvest block, or lakeshore. These areas are often cooler, quieter, and offer protection from some kinds of predators. Our goal is to define where these interior areas are in a clear and repeatable fashion, so we can make management decisions in that context. We have a LiDAR-derived canopy height model for our woodlot, which shows the height of the vegetation in each pixel, and each one of these raster pixels is 1 square meter. So we can see in this pixel the height of the vegetation off the ground is going to be 7.61518 meters. So this canopy height model is a continuous model, and the first thing we're going to do is reclassify this into a binary yes or no. And we are going to use the height of the vegetation to define whether or not the area is part of a forest opening. We're going to use a height of 3 meters, so if the vegetation is 3 meters or less, it is going to be part of a forest gap, and that is going to affect our analysis of forest interior. So we're going to search for tools, reclassify. 3D or spatial analyst, whichever license you have, will work. Our input raster is our canopy height model, and we are going to classify that not into 9 classes but into just 2, and we are going to set our break value to 3 meters. So now we have pixels that are part of a forest opening, a very recently harvested block of 0 meters all the way up to 3 meters, so it was maybe harvested 5 or 10 years ago. And then we have all the other forest. Okay. So now we can see we've simplified this raster down to just 2 values, 1s and 2s. The 1s are part of a gap. That can be the road. That can be a recent harvest. This can be a partial harvest where you can see the skid trails in here. Older partial harvests, you can see the remnants of the gap where the forest canopy has closed in some places. Our next step is going to be to take this from a raster dataset to a vector dataset of polygons. So we're going to search for the tool raster to polygon. Conversion. Input raster is our reclassified raster, and we are going to keep simplify polygons checked because that's going to speed up the step number 4 here. Okay. Think. Good. So now we have a vector data layer where the attribute is the same as the underlying grid code. So grid code equals 1. That is part of the road, which is a gap in the canopy. Now we only want to have those where the grid code is 1. We don't want grid code 2 because that is forest. So we're going to go into the attribute table, right click, open attribute table. We are going to select by attributes where grid code, double click, equals 1. Apply. And that has selected all of those where our grid code is equal to 1. Now we can close that. Let's zoom to this layer and see what we're doing. And we can see that only grid code 1 has been selected. Now we want to export grid code 1, right click, data, export data. Setting that to my discard folder, and that is going to be canopy openings all. You'll see why all in just a moment. Yes, I do want that added. I can stop displaying the rest. Let's just make that a nice obvious red so we can see what's going on here. Don't need an outline right now. So here are all of our forest canopy openings. Let's zoom in and have a look here. This is a recent partial harvest. This is a less recent partial harvest where the skid trails have grown in. But what we can see if we zoom in here, we have a lot of these little tiny sliver polygons. And every one of those is just a space where maybe there's a gap between two trees. That's something that happens in mature forests. That doesn't constitute an opening in the context of our forest interior analysis. So we are going to select only those polygons that have a certain area to them. We're going to use a cutoff of 500 square meters. We're going to go back into the attribute table, right-click, open attribute table. We're going to make another query, select by attributes where shape area, and that's in square meters, is greater than 500. That's going to select 47 of those polygons. You see that selection is just the big areas here. This recent partial harvest is selected. That's going to be pertinent to our analysis. This older one, this is closed in so much we are right now considering this to be a closed forest. So let's zoom to the full layer again. And now we're going to right-click data, export data again. And we are going to call that Canopy openings 500 meters. Yes, I do. Uncheck that. And now if we turn that to a bright yellow, we can see that we have now only the big gaps and openings in the canopy. So we have our recent partial harvest, our recent clear cut, our somewhat recent clear cut. This was actually done 5 or 6 years ago. I happen to know that from prior work. And these are lake shores and boggy areas. So is this. This is a natural gap in the canopy. This older road is grown in. You can see there's a small gap there that didn't fall into our analysis. That's something we can be critical of later as we're deciding what to do with this. But it looks like we've got our big canopy gaps here. So now our next step is to buffer those gaps. And right or wrong, a value of 100 meters is used pretty well around the world as a value for defining forest interior. I've seen this in the United States. I've seen this in documentation from England. It's up to a real wildlife professional to say whether a particular species needs more or less than that. We'll use 100 meters. Dissolve type is going to be all. Let's see, our side type, we're going to keep that full. Everything else is fine. Go, think. Before, when I tried this without simplifying the polygons, it stalled on this step for an hour and a half and ended up with no meaningful difference in our actual output. So with the simplified polygons, here we are. So now we have a buffer around every one of these large canopy openings, but that leaves us with the area that is forest edge. We want the opposite of that, so we are going to have to essentially flip this. So we have a polygon that is the boundary of our woodlot. Turn off everything else here. So this is just the woodlot boundary. This is all the area that we have to work with. These are the buffers, so we are just going to finalize this with the erase tool. And that is going to act like a cookie cutter, the opposite of clip, really. And we are going to have our woodlot boundary as the input and our buffered area as the erase feature. And that is going to leave us with only those areas that do not overlap with our buffer, which means we've left the interior habitats. So let's review what we've just done. We've reclassified our canopy height model to a 3-meter height, which means that anything 3 meters or less is a canopy opening. We've converted that raster to polygons. Selected grid code equals 1, which means canopy opening. We've selected only the big canopy openings. This is a moving part in the analysis. With consultation with a professional in your ecosystem type, you might use a different value than that. Then we buffered those canopy gaps and used the erase tool to flip and give us only those areas of forest interior. So now our final step, as always, is going to be assess our results. We are not just going to accept these, so let's make these black. We don't need any kind of a outline on those. Let's go ahead and make that transparent so we can look at this over an air photo. So I'll make that 70% transparent. There's our air photo. And we can see we have, this passes the straight face test. We have a stand type boundary, hardwood, softwood, but all of this is far from any opening. That's legitimate. This is a place where you might consult with a wildlife professional and make some kind of a judgment call, because you have this gap here and several other gaps. These are, looks like you might have a couple of beaver flowages going along this stream. This might actually be great interior habitat. This is flanked on each side by areas that are definitely interior, far from these openings, far from this road. So this might be a fantastic place to conserve for wildlife for a variety of reasons. This is a smaller patch of forest interior, but it meets all of our criteria. It's 100 meters from this road and this road. But this is getting up to a boundary where you might have to consult with your neighbors. This is a different landowner, but this is definitely looking like a continuation of the same forest type. So if your neighbor also had an interest in conserving forest interior, you might make an arrangement with them to make a continuous spot there. Here's a place where this canopy gap is a natural wet area, again like that area down to the south. This might be great forest interior habitat, or a great habitat of some kind. It's surrounded by interior, far from the road, gets up to this lake shore, which it might provide access for some predators. It might have different habitat values, but if you can combine this interior with this natural edge along the lakeshore, that might be a great spot as well. We have more places where you're abutting a neighbor. This spot here, this patch of interior is actually going to be less than 100 meters away from your neighbor's clear cut, which is an issue you might have to address when you're actually implementing this. But we've identified locations that are potential forest interior habitat for conservation purposes, which is our goal, and in consultation with wildlife professionals, we might decide to prioritize one location over another, but this analysis is easily repeatable. You can easily change the parameters from gap size of 500 meters or maybe 1,000 square meters is more meaningful, or perhaps 200 square meters, depends what you're looking at. But areas like this where the canopy has closed in over the road, those fell out of the analysis. You might be more conservative by including not just your LiDAR-derived canopy gaps, but if you threw in a buffer around the line representing roads, you have a transportation layer here, you could buffer that, add that to the buffer that came from the LiDAR, and have a more conservative estimate of your canopy gaps. Because maybe you know you're going to go in here and yard some wood out and truck it out here, so this little bit here, this might not be forest interior for that purpose. Anyway, that's the starting point. You can jump off from there. We're going to use this in lab number 9, I think, so we'll be building off of that as we go.